I'm racing against the clock here to get this done before the next period, but let's get cracking with solving some equations. So I've just written the steps down here. So expand brackets, simplify if you can, and then solve with backtracking. Now, before I start, I know that here I could take the 3 over and then divide it, and then deal with my x minus 2. That totally works for this equation because it's quite short, but later on when we get to longer equations, you're going to need to do this way. So I'm going to show you that today. So the first step is to expand the brackets on this side. Okay, so 3 times x, 3x, plus 3 times 2 is 6, equals 18. Okay, and I did notice some people were doing this naturally with some other expressions prior to this, so that's fine too. Now I simplify if I can. Now if I look here at this part of all my like terms are together anyway, so there's no extra x's, there's no extra numbers, so I don't have any work to do there in this example. Now I just do my solving with backtracking. Okay, so you can do this with a flowchart if you wish with the boxes, but the normal way we've been doing it in class is a little quicker. Okay, so here I'm going to go minus 6 minus 6. So I've got 3x equals 18 minus 6 is 12. And then divide by 3, x equals 4. Now, just to be pedantic, if you look at my setting out here, I've got all of my equals in roughly the same place. Okay, and I've just shifted my working over to be closer to my equals. That's really mathematical and logical. It's a great idea. All right, here's an example, don't freak out, where I've got the majority of my expression on this side, on the right-hand side, and my answer on the left-hand side. That still is totally normal, perhaps different to the majority of examples we've done in class, but pretty straightforward. Okay, don't freak out just because they're in an opposite place. Like if I have 2 times 3 equals 6, that's the same as me writing it this way. Okay, so same. All right, so first step is to expand my brackets. So I'm going to go 7 times 4q. I'm still going to write my 7 equals at the start. I did that with the first example too. 7 times 4 is 28q minus, because that's the minus that's in the brackets, the operation that's in the brackets, 7 times 3, 21. Okay, now I'm going to simplify if I need to, but again, this example has all my like terms together, so I don't need to do any more work there. Still going to write my 7 equals. Now I'm going to plus 21. Oh, accidentally wrote the answer there. Plus 21 on this side and plus 21 on this side. Okay, now equals 28q. Now I have 28 on this side equals 28q, and this is timesing, so I'm just going to divide. Okay, now I have q by itself on this side, and 28 divided by 28, 1. So q equals 1. Alright, I literally have 1 minute, so let's see how we go. This is an example where it's really handy to expand the brackets first, and I'll tell you why as we work through it. So number 1, expand the brackets, okay? So 3 times b is 3b, plus 3 times 5 is 15, plus 4b equals 29. Okay, if I didn't expand my brackets first, I'd be putting a 4b on this side, a divide by 3, and then moving the 4b over. So it's just really better if we do this and gather our like terms together. So now I've got a 3b and a 4b, so altogether I've got 7b plus the 15 equals 29. Okay, then I'm going to deal with the plus 15 by minusing it here and minusing it there. So now I have 7b equals 14. Oh, that's the bell. Let's see how we go. Now I have a 7 that's remaining, that's timesing, so I'm going to divide by 7 each side. That's going to leave me with b by itself, which is exactly what I want, and 14 divided by 7 is 2.